People tend to think of the states of matter to be clearly defined, immutable, solid, liquid, and gas, all separate from one another. This simplified conception of matter could not be more wrong. Ooh-Bleck.
To define a non-Newtonian fluid, we must first investigate what a Newtonian fluid is. In simple terms, a Newtonian fluid's viscosity, that is, its resistance to flow, is consistent at all times. Fluids like water, that will always deform the container's shape at the same rate, despite the given stress, are Newtonian. From this, we can conclude that non-Newtonian fluids do not follow this law, and that they are weird. The viscosity of a non-Newtonian fluid changes depending on how much stress it is under. If force is applied, the fluid may flow more freely, or, as in the case of Ooh-Bleck, it may become more viscous and even solid.
Ooh-Bleck is a non-Newtonian fluid made of cornstarch and water. It's a shear-thinking fluid, which means that the more force is applied, it becomes more viscous. If I actually apply enough stress onto the Ooh-Bleck, it will become solid. The way this works is that the Ooh-Bleck upon which force is applied actually forms an iceberg like solid. As you can see, first the surface Ooh-Bleck solidifies, and then the part underneath it applying slightly weaker force, and so on, until there is an iceberg-like shape of solid.
This makes a lot more sense now. Okay, I was wondering whether we were doing force or pressure, and this makes a lot more sense. Okay, so if we're doing what I originally thought was force equals mass, right? Times acceleration. But then so it would be like F equals ma, and a would be gravity, so we could change that to g, so it would be like F equals mg. But that's not what it is, because F equals mg is actually equal to weight, which is why you're lighter on the moon. So that makes lots more sense, because pressure is force over surface area, or it could be weight over surface area. So now everything makes sense. Force is mass times acceleration. So how much matter is being dropped at what acceleration is how much force is being applied.
The thing about Ooh-Bleck is that the viscosity changes depending on shear stress. Shear stress, as opposed to regular stress, is parallel to the surface. Regular stress goes this way. So like things like scissors work through shear stress. And to explain viscosity, viscosity is how things, like how they resist to flow. Because if something is solid and it's dropped in a container, it's not going to change its shape. Unlike liquid, which will automatically change form to the container which is filled in. So what happens here with Ooh-Bleck is that when force is applied, there is actually a part where the direct force is that becomes solid. And even though you can't see it because it's still within the other mass of liquid, the iceberg that forms is solid, and it keeps its shape, which is why when something drops into Ooh-Bleck, there's a dimple that forms before it actually sinks down inside, because the viscosity has once again returned to normal. And that's how Ooh-Bleck works.
What we want to test is just how much force needs to be applied for Ooh-Bleck to become solid upon impact. To do this, we're going to fill a clear container with Ooh-Bleck and drop another container into it while recording everything with a camera. The weight of the second container will decrease until we find the force at which Ooh-Bleck does not solidify on impact. Basically, we're going to drop a lunchbox filled with water into a bigger box filled with Ooh-Bleck. It is very scientific.
So as you can see, we're using a variety of tools to implement our experiment, or as I like to call it, implex-experimentation. Here is a genuine plastic bin from IKEA, which I've sectioned off with red plasticine. And so this is actually where we're going to put our Ooh-Bleck. While here is the cornstarch we're going to use to make our Ooh-Bleck. the water, and the lunchbox, which we will actually be dropping into the Ooh-Bleck. We'll also be recording everything by writing it down and filming with this camera, which you can't see because it's filming this segment.
We will be using 1,225 milliliters of Ooh-Bleck with a water to cornstarch ratio of 425 milliliters to 800 milliliters and experiment using weight increments of 5% of the total amount. The lunchbox will be dropped from a height of 30 centimeters and the surface area of 192 centimeters squared will remain the same as it is the same lunchbox. From our continuous mucking around with Ooh-Bleck, we found that it does not solidify unless significant force is applied. From this, we can hypothesize that Ooh-Bleck will cease to solidify on impact at around 306.25 milliliters of water inside the lunchbox to form a total of 429.25 grams dropped in the Ooh-Bleck.
So let's get started. 1. It still scares me every time. Okay. 3, 2, 1.
That was still pretty solid. It wasn't as good as the 0.5.
Three, two, one.
It's starting to become really liquidy now.
Yeah.
It's solid, but it's not as solid.
3, 2, 1.
Oh, that's still solid. One foot drop. 3, 2, 1.
Still solid. 3, 2, 1.
Still solid. It's getting less solid, but still solid.
Less solid, but you know.
Yeah.
One foot drop. 3, 2, 1.
3, 2, 1. 3, 2, 1. Just barely. Okay, 1 foot drop. 3, 2, 1. Ooh.
I have no idea. We'll have to see that one on tape. I would say that our experiment was very successful. Although things didn't go exactly according to plan, that's how experimentation works. It's alinear, like Ooh-Bleck's viscosity.
Our hypothesis was that the Ooh-Bleck would stop solidifying on impact when a pressure of 2.24 grams per centimeter squared was applied, but that didn't happen. Clearly, we underestimated the sheer thickening power of Ooh-Bleck and how much force that a small lunchbox drop from 30 centimeters would produce. Even with the lunchbox completely empty, its own weight, surface area, and accumulated force from acceleration was enough to instantly increase viscosity.
It turns out that the divide between states of matter isn't so solid after all. Although it's disappointing that we're 0% right, we did learn a lot about non-Newtonian fluids, particularly Ooh-Bleck. Under stress, this material literally changes the way its molecules behave, much like science students in exam season. If anything, we're more in awe of this material than ever because of this experiment. Starting with nothing but a fluid idea and sheer curiosity, we've conducted a stressful study.
Corny jokes aside, this has been an educationally satisfying experience for both of us, and we hope that our experiment has made you go,
Ooh-Bleck. Alright, that's a wrap. Nice job, everyone.
Good job! Yeah!
Okay.
Alright, I'm really sorry. I'm really sorry. Emily made me do this. The hypothesis, the experiment was completely her idea. I did nothing. Everything's wrong, blame her!
What are you doing?
Here we go! Pressure of 2.24 grams.
So disappointing.
Wow. Hell yeah, I got it. High five. Wait, hold on,
Oh yeah, what?
High five.
Do your vocal exercises.
Magic! It's changed the counter.
Oh yeah, we had some stolen before.
Okay, I'm gonna read off a lot though, because
Father.
numbers and stuff.
Yep, alright.
What are you trying to do?
See when it doesn't go solid.
It's called science, Cam.
Beetle, the Caesar.
Was that the Ooh-Bleck? Oh my god. Don't use too much force, Emily.
You need your goggles for this part, so.
That,
They're rad.
clap your hands, clap your hands.
New Repair and Protect Pantene. Hair so healthy looking it shines.